In this video, you will learn how to predict price of a used car using XGBoost. We will also compare the XGBoost model results with other regression algorithms like linear regression, decision tree, and random forest regression. Let's read our CSV file first. First, I'll import the pandas. Import pandas as PD. Now I'm going to make one variable df. I'll read the CSV file pd.read underscore CSV. Inside this, I will pass the CSV file name, which is cars underscore data.csv. I'll share this CSV and the notebook with you. You will find the link in the description below. Now let us execute the code. Let us look at the head of our data frame, df.head. And here in the output, you can see this is our data frame, and we have several columns such as make, model, type, origin, drivetrain, MSRP, engine size, and etc. So these are the variables that we have in our data set. And in this data set, our target variable is MSRP. So this is the price of our used car. Now, in able to use this as our target variable, first we will need to clean this variable, because you can see that we are having the dollar symbol with the numbers here. So we are going to clean this variable first before we can use it as a target variable. And let us explore our data set. So this is the head of the data set, and now let us look at the tail of the data set. So these are the top 5 rows, and to get the tail, we will use df.tail, and these are going to be the bottom 5 rows of a data frame. Now we can also check if there are any missing values. So I'll write here df.is null. So here we are getting false, and if I type here .sum, we will get it column wise. And here in the output, you can see we have 2 missing values in this variable cylinders. So what we will do is we will remove these missing values and save the data frame in a new variable, or we can override this. So I will call this df, then I will call df.drop_na, and this will remove the missing values from our variables. And let us execute the code. Now if I do this similar operation here, if I run this code again, here you will see 0 because we have removed the missing values. Let us execute this code, and now here in the output, you can see now we are having 0 missing values here. So because there were only 2 missing values, that is the reason we have removed the missing values from our variable cylinders. Now what we are going to do is we are going to clean this variable MSRP to use it as a target variable. Now what I will do, I'll call this df, and then the variable name is MSRP. I'll copy this from here, and then I will paste it here. Then I will assign here df of MSRP, and first is what we are going to do is we are going to replace dollar, which we see here in this variable, and let me print that variable here. So I will write here df.head, and let me print just 2 observations. So this is how the variable looks like. And now we need to remove this dollar and also this comma. So we will use string str, and from this we will use the method replace. And what we want to replace, we want to replace this dollar. So we will write here dollar, and against this dollar what we want, we don't want anything. So we will write here just empty quotes here. Now I'll copy this from here, and I will paste it here. Next, what we have to do, we have to replace this comma. So here I will type here comma, and this will remain as it is because we don't want to put anything else. We just want to make it as it is. We don't need anything here. We just want to remove this comma and keep it as blank. So that is why I'm keeping it as blank. And the next one is, so here you will see the type is object, data type is object, If you want to look at the data types of any variable, so you can type here df.dtypes. I have pasted all the libraries here and I will press enter. Now I'm importing all these libraries. Now the first thing that we are going to do is we will do visualization here. We will make some beautiful plots here. First we will make a pair plot. So what I will do, I will call here SNS. This is from Seaborn library. You can see here we have imported Seaborn as SNS. So I'm writing here SNS dot pair plot. And then I will execute the code here. Now here in the output you can see that we got a pair plot for each of our variable here, and here you can see the variable name is written here MSRP. Then we have engine size, cylinders, horsepower, MPG only, MPG highway, weight, and so on. We have made the pair plot of each variable here, and you can see this pair plot looks really beautiful. Now we will make bar plot of categorical variables using histogram function from plotly library. Now let us make that. So in our variable, let me print the column names. So we have these column names here, and let us make bar plot of this column make. So first what we will see, we will find what are the unique values. I will write here df.make.unique, and you can see there are so many unique values in this variable. So what I will do, I'll make a very beautiful plot using plotly, and once I'll make this you will see how beautiful it looks. So I will write here figure. This is going to be a variable, then px. So here we are importing the plotly library. First let me show you here. So here we are importing from import plotly.express as px. So in our upcoming tutorials I'm going to make a new series on plotly where we will see from scratch how we can make these beautiful plots one by one. And for this purpose you just remember that from plotly we are importing this import plotly.express as px, and that is what we are going to use here, px dot histogram. Then inside this we will pass our data frame, which is df. Then on the x-axis we will have this variable make. Then we will provide labels, and this is going to be our dictionary. In this our key is going to be make, which is the variable itself, and then the value will be manufacturer. Then we will give the title. Title is going to be manufacturer of the car, and then we will pass one color underscore discrete underscore sequence, and let me put it as red, and then we will call this figure.show. And now you will see the beautiful plot here. Let us execute our code. We got one error here, title. I have to make here spelling correction. This is title. Let us execute our code again, and this time we should be able to see a beautiful plot here. And here in the output you can see we have a very beautiful plot. So we have all these manufacturers here. So we have Volvo, Volkswagen, Toyota, Suzuki, and so on. All these are the manufacturer of the car, and we are getting the bar plot again. So if you click on this bar you will get the manufacturer here. So manufacturer here is Mercedes-Benz, and how many car it has 26 cars. For example, here the manufacturer is Toyota, and the cars are count is equal to 28. There are 28 cars. Similarly, we can make many more bar plots here. For example, so now what we have to do, we just have to copy this code from here, and we have to paste it here, and then let's say we will select here model, or let's say we will select here origin. So here I will type origin, and then here I will type origin, and I will type here origin of car, and here also I will type, let's say, origin of the car, and color I will give as blue. And here in the output you can see that we are getting these countries here. We have USA, Europe and Asia. We have most of the cars from Asia here, and the origin of car is Asia. Count is 156. For this we have the count 123, and for USA we have 147. This is how you can make all these beautiful plots here. Now let us make a heat map of correlation matrix. So first we are going to find the correlation. So for that I will write here df.core, and this will give us the correlation matrix. So here you can see this is our target variable MSRP, and we can find the correlation of this variable with respect to the other variables. So MSRP, the correlation with this variable horsepower is 82%, which is quite high, and with this variable engine size it is 57%, cylinder 64%. With MPG highway we have a negative correlation of -44%, and we have a very less correlation with wheelbase, which is 15%, and length is 0.7%. So this is the correlation matrix, and we can also make a heat map of this correlation matrix. For that I will write here plt dot figure, and then figure size is going to be, let's say, 18 by 18, and then I will write here sns dot heat map, and then I will write here df dot correlation. This is a function. Then this parameter cmap color map. So we will write here, let's say, YIGNBU, and then annotation is going to be true. I'm not sure about this color. I hope it should work, but I think this is not working. A YIGNBU is not a valid value for frame. Let me paste something else from here. I'll copy this from here, and then I will paste it here. Okay, so we got a color here. So you can paste one of the color from the error that you got. So this is the correlation matrix or the heat map, and here also we can see we have this target variable MSRP, and then we have correlation with each variable, and you can see if all the variables are having correlation 1, that is the variable with itself is having correlation 1, and that is written in 111 here. So this is the heat map. From this you can also interpret the correlation matrix or the correlation of target variable with respect to the independent variable. Now what we are going to do is we will do the one-hot encoding of a categorical variable like make, model, type, origin, and so on, so that we can use it in our ML model. As you know that machine learning model only understands numbers, we cannot pass categorical variables, so we need to do the one-hot encoding of these variables, and for that we can use the dummies from pandas. So what I will do, I'll make a new data frame df underscore new, and then here I will write pd.get underscore dummies, and inside this I will pass here all the categorical column names. So let us find all the categorical columns here. So here I will type df dot d types. So whatever variables you see are in object, these are the categorical variables. So let me paste here df dot columns, print it here. So we are going to copy this drivetrain, origin, type, model, and make, because these are categorical columns and we need to convert it into numerical. So here I will pass our data frame df and then columns is equal to, I'll make a list, and inside this list I will pass variables from make to drivetrain. So I will just copy it from here and then I will paste it inside this list here. Now let us print df underscore new dot head, and here in the output you can see we have this new data frame here and we have so many columns here. So here you will see we have 482 columns, and if I print the shape of this new data set df underscore new dot shape, so here you can see we have 426 rows and 482 columns. There are so many new columns here, and earlier we had 426 rows and 14 columns only. Because we have created dummy variables of categorical variables, that is why we have got new 482 columns here. Now what we are going to do is we are going to split this data set into x and y. So x will have our independent variable and y will have our target variable. I will write here x df underscore new dot drop. In x we will drop the column msrp, which is our target variable, and we will select all the other columns. This is going to be axis is going to be 1, and in y we will have df underscore new just one column, which is msrp, and let us execute our code. And if I type here x, so we have this, the entire data frame we are having except the column msrp, which is our target variable, and in y we will have just msrp. So if I type here y, we have just msrp here. Now let's convert our x and y into arrays or numpy arrays. So I will write here x np dot array of x, and then y np dot array of y. Let us execute our code. Now we have both x and y as our numpy array. Now from scikit-learn import the train test split from scikit-learn dot model underscore selection, and from this we will import train test split. Now I will write here x train, then x test, y train, and y test. Then I will call this train test split. Inside this I will pass our x and y, x and then y, and then test size is going to be, let's say 20%, 0.2, and then random state, so I'll write here 0.2, and then randoms, then we have this random state. You can put any number here. I'm putting it here 1. If you want your result to be same as mine, then you can put 1 here. Let us execute our code. So we have done this splitting. Now first we are going to fit the linear regression, then decision tree, then random forest, and then finally we will fit XGBoost, and we will see the difference between all this algorithm, in which algorithm we are getting the highest accuracy. So let's start with the linear regression. I will type here linear regression. So let us import linear regression from scikit-learn dot linear model import linear regression. Now I'll make an object of this class. So I will write here linear underscore model is equal to linear regression class, and then I will call this linear model dot fit x train and then y train, and then I will find the score here, model dot score on x test and y test. So we don't have x test here because I have to put this as capital letter x test. Now you can see here in the output we are getting 63% accuracy in linear regression. Let's do for decision tree now. Decision tree regression. So what we will do, from scikit-learn dot tree import decision tree regressor, and then I will write here decision dc underscore model. Then I will import this class. I will make an object of this class. Then I will write here decision model dot fit xtrain and then ytrain, and then I will do decision model dot score xtest and then ytest. And here in the output you can see we are getting even lower accuracy in decision tree, which is 58%. Now let's do the same for random forest regression, or you can write here regressor from scikit-learn dot ensemble import random forest class regressor. Now I will write here random underscore model, and then I will make an object of this class random forest regressor. Then I will fit it random model dot fit xtrain and then ytrain, and then I will find the score dot score underscore xtest and then ytest. And here in the output you will see for random forest we are getting accuracy of 80%. So for linear regression 63, decision tree 58, and random forest is 80%. And now let's do the XGBoost, which is the main topic of this algorithm of this tutorial, which is the XGBoost algorithm. Now let's import it from XGBoost import XGB regressor. Now I will write here XGB underscore model, and then I will call here XGB regressor, and then I will fit it dot fit xtrain ytrain, and then I will find the score model dot score. We have xtest and then ytest. Now let us execute our code. So for XGBoost we are getting an accuracy of 76%,